Today we're going to be graphing some of these arithmetic sequences. So if you haven't already guessed that, there's not too much to these sequences. So if I have a sequence defined as t1 is equal to 6 and d is equal to 5, and I want to graph, let's say, the first 5 terms. Alrighty. So, well, first of all, let's just figure out what the first 5 terms are. So if our first term is 6 and it's going up in 5s, it's going to mean 11, 16, 21, 26. Those are the first 5 terms. So this is our Tn is going to be equal to each of these. So we can actually draw this up like a table. I know most of you probably won't need to draw it up as a table, but I often find that it's easier to visualize with a table. So the way we can do this is we've got the first term, second term, third term, fourth term, fifth term. We don't have a sixth term. And that's going to be our n, and this is going to be our t of n. Alrighty, so our first term was 6, our second term is 11, then 16, then 21, and then 26. And this is going to be like our explanatory variable. This is going to be like our response variable. We're going to draw it up just like a graph. Alrighty? Except instead of having x and y as our 2 variables, we're instead going to have n, the term number, down here, and then up here we're going to have t of n, the term itself, the term. Alrighty, so let's actually just go through. So we're going to have 1, 2, 3, 4, 5. And then we'll start at 0. And we'll go up in 5s. 5, 10, 15, 20, 25, and 30. Ready? And so before we actually graph it, I want you to have a think about what do you think it's going to look like? Because a lot of you might realize that these look a lot like linear equations. So we'd almost imagine we should get something that looks pretty straight. Because remember, in a linear equation, y equals 3x plus 2, it's just going up by 3 each time. That's the gradient. And we're doing the exact same thing. And indeed, if we graph all of the points, so there's 1, 6, 2, 11, 3, 16, 4, 21, 5, 26, you can see that they are indeed a straight line. However, we don't actually want to draw that straight line in. Because of the way that these sequences work, they're only defined for when n is a whole number. We never talk about n being like 2.3 or 2.5. We don't have the 2.7th number. That doesn't make much sense. The point of these are to only work with the whole numbers, at least for the term number. The terms can be decimals, that's fine, but for the term numbers themselves, they need to be whole. Alrighty, so that's how you draw a graph. I might go through one more just so we can see it, but then you guys can go on your merry way. So let's do one where there's going to be some negative numbers, so I'll go 7. Oh, let me fix this up. Alrighty, so once again, let's sketch the first 5 numbers. You can see I've got 3 numbers in this sequence so far, so we've got to work out the next 2 as well. So the common difference might be a little bit hard to see, but remember you can always just subtract subsequent terms or pairs of terms. So 8 minus 17, negative 9. So it's going up by negative 9. And same for the next one. And so we can just keep subtracting 9. And so we're going to get negative 10. And the last term we're interested in is going to be negative 19. Alrighty, so let's draw up our table and then draw up our graph. Alrighty, so our numbers are going to be 17, 8, negative 1, negative 10, and negative 19. So this is going to be another one of our strange ones. We're used to drawing like a Cartesian plane where we have both positive and negative. In this case, we only need the positive x-axis or the positive n-axis, and we need both positive and negative on the vertical. So we draw a sideways T like this, and that's going to give us all of the space we need. So we've got n over here, we've got t of n up here. This is going to be 0 here, and we've got 1, 2, 3, 4, and 5. And we need to go up to 17, down to negative 20, so let's go up in 5s, 5, 10, 15, 20, negative 5, negative 10, negative 15, and I need to go all the way down here, negative 20. So I might just extend that a little bit. So remember, always plan out your axes. There's no point in rushing straight in, because you'll often find that you end up making mistakes. So now I can just plot all my points. So we've got 1, 17, 2, 8, 3, negative 1, 4, negative 10, and 5, negative 19. And you'll know you've done it right if your points are nicely fitting on a straight line. And you can see it's pretty accurate. Not perfect, but pretty good. And that is how we draw graphs with arithmetic sequences. I'll see you in the next one. Goodbye.